Okay, carrying on from the first video, we're going to look at the rest of the main Pi code. We'll basically run through all the code, the main loop, and then try running it. So first, there's a whole bunch of imports. First thing that happens is between lines 35 and 39, where it's setting up the Wi-Fi interface and also setting the LED pin so we can flash the LED on the board as things go on. Then there's all the function definitions, and we've seen some of those already, so let's go into the next main piece of code. Is line 115 here, uresults.reset. So remember previous video 8a, I created the uresults library, and there's a reset option, and basically that goes in, make sure there's a results folder. If not, it creates it. If there is a results folder, it'll delete all the results file in that folder, so after a reboot it's basically starting from scratch. Then we've got the main loop. Like I said, in production this will be a continuous while, so it'll be a while true, but for testing I only want it to go through twice, so I've got a for x in range 2. Some comments about what the main loop does. As I said, there's 3 parts to the main loop: the MQTT logic, the code that does the probing based on what's in probe config, what probing is requested for this device, and then finally the governance loop, where I'll slow things down to whatever speed I want the overall speed of the loop to go. So running through the MQTT logic to 132 to set up the Java Web Token. The next code, 134 to 135, there's a request to the MQTT client to check for messages. So remember we set up the subscription earlier, so this is going to check if there's any messages on that subscription, and if there is, then we'll check whether the topic config returned any messages. If so, the callback saves those messages to the probe config.json file. So line 135 is calling the uprobe config library, doing a get on it, which returns an object of the JSON that is in that uprobe config file and puts it into an object probe config, and then I just print that out. Next one, 139 to 150. This is the main logic if there's any results in the results folder, to send those results up to the Cloud IoT core. So first we get a list of file names of any results that are in the results directory. It processes those files one line at a time, and just for a bit of visual feedback, I'm using the LED here on the board. I'm actually doing a reverse flash, so flashing by turning it off and on, probably up to 500 milliseconds, or at least 500 milliseconds. So basically what I'll be looking at on the board is during the main loop, this LED will be on, but when it's sending data up to the Cloud IoT, that light will flash off. So the first part of it will be getting the results of the particular file name. So remember, we're iterating through the file names in the results folder. Gets the first result, and then it's going to publish that result. And once it's published, then it's going to remove that particular result, or the file name of that result. Sleeps for 500 milliseconds, completes the flashing of the LED. And that's the end of the MQTT processing in the main loop, so we can do a client disconnect. Next part of this is where we do the actual probe tests, so 157 up to 173. So first we look into the probe config. So remember we read in the probe config object earlier. Inside that object is a property called probe list, which is a list of probes or network capability tests to perform, and it'll iterate through that probe by probe. So the first thing, all my probes at the moment are the only capability tests I've set up is the Bing test, a test for latency and bandwidth. So at the moment it's just defaulting to this one test. In future, as I have other probe types out defined, then there's going to be more of a case or an if statement to drop through and do the particular tests requested by that probe. So for now, it's always going to be Bing, so let's pull out the target from the probe information, do the Bing using the Bing routine you saw in some of the earlier videos that I set up. If there's no Bing results, so it could be that the Bing failed because maybe the longer pings took less time than the shorter pings, so it'll just return none in that case. We'll get it next time around. So sometimes you have some weirdness like that with pings and whatever's going on in the network. But if it did return a value, then it's going to set up a result object, which has been defined here. Notice things like probe ID is coming from the probe that we're processing at the moment. So again, you can think of it up on the Cloud IoT server. We've got configs that has a list of probes that are defined, and probes are going to have a unique ID. So all the tests that are done using that probe definition will all have the same probe ID. The probe's also given a UMT time. So the time that particular instance of the probe was executed, that's going to be in UMT time, so basically a Unix formatted time in seconds past start of 1970. That's going to be UMT, so it won't be taken into account the time zone of the device. It's just going to be the standard based on network time of what the universal time is at that time. Then the things that are returned by the Bing, the bits per second, the target, and the round trip latency. It's going to add it to we'll use the uresults library and the add. So we saw again in the previous video what that uresults library looks like, which gets past the results object, which goes and saves it to a unique file under the results folder to be picked up, as we just saw a little bit earlier, in the MQTT processing to be set up and sent up to the Cloud IoT core on the next loop. Finally, part 3 of the main loop is the governor. So I've got a bunch of print statements in here. So what it's doing is working out this part here, number of seconds that have already elapsed since the start of the loop. So you would have seen at the beginning of the loop that the loop start time was saved, and then we subtract that from the current time. So how many seconds since the loop started. Subtract that from the governor seconds, which came from our config properties up on Cloud IoT. So say if we only want it to loop a maximum of once every 5 minutes, we've already spent say a minute in the loop, so it'll only sleep for the remaining 4 minutes. So that's what that sleeper value is. So if the results of that calculation is sleep is greater than 0, then basically we sleep for that time. At the moment I've got that commented out for testing, so I'm just sleeping for 5 seconds. I don't have to wait up to 5 minutes for every loop to complete, but in production I'll just swap these comments, so sleep will actually sleep the required amount of time. That's the whole thing. That's the whole loop there. Again, for testing, I because I'm only looping twice, it can drop out, so I have the disconnect from the network. In production, this loop is continuous. It's going to be a while true, so it should go on forever. So that's the code. Let's try running it. So I'm going to go down here. I'm going to connect up to my ESP32 through COM3. We should be ready to go. So I'm going to click on main Pi and do the run. So it's connecting to the network. That was successful. It's got an IP address. It's gone out to network time and got the current network time. It's creating the Java web token. It takes a little bit of time. It's actually been taking the majority of time in the loop. So it takes about 20 seconds for it to calculate that. So it's got the web token. Now it's going to do the pings. And you'll see here it actually failed. And if I go and have a look in uping, I can see that get random string is failing allocating bytes. So remember that we're running on a microcontroller, has restricted memory, something like 500k of memory, less of that allocated to the heap. So we're running into problems with things like heap fragmentation, finding a large enough part of the heap for doing the allocation. I still want to check the rest of it's working, so I know I've got a problem in ping. So what I'm going to do is actually, you remember from one of the earlier tests that for Bing, when I created the Bing routine, I set up this uping stub, which basically doesn't go out to the network, doesn't do half the processing of the real ping, just returns some values for the Bing. So what I'm going to do is in the uping, I'm going to import uping underscore, which is the stub version of uping. Really doesn't use any memory at all. Looks good. I'm going to save that. I'm going to upload everything, so it also does a reboot of the microcontroller. So memory should be cleared out. I'm going to go back to main Pi, try running this again. So I'll do the same thing. It'll connect to my Wi-Fi network. It'll create a Java web token. Hopefully this time it should make it through where it got hung up on Heap the last time, because it's just doing stubbed out ping, not really using memory much at all. So we'll see whether the rest of the routine works, where if we wanted it to run through twice, doing the pings. Okay, so that looks successful. It wrote out a couple of results. It's doing a sleep. Remember, it's for testing. I'm just sleeping at 5 seconds, so it's started getting the network information again, getting the current time, creating the Java web token again. So this is the second loop through. So what it should do is send the results up after it gets the MQTT connection. So there you see it's sending results, finishes all the MQTT processing, did another series of pings, made it through, and basically on the second loop it dropped out and disconnected from the network. So other than having heap problems when it's executing the ping, the overall logic seems okay. In the next video I'm going to go into some optimization of the memory and the heap to try and get this whole thing working without problems and have a real ping going. But one more thing just to check that it's all working. Let's go up to Google Cloud Console. PubSub. Look at my subscriptions. View the messages. So this should be the messages that came in from the client. And at 350, and it's 352 at the moment. So these are the ones that were just sent. So remember, on the first loop we did that stubbed out Bing. Saved the results of those to the result folder, and then the second loop, the MQTT processing picked up those results, and here we see it's successfully sent it up to the Google Cloud IoT service for the 2 probes that are active. This won't be very interesting because it's just pretend code, so watch the next video now, and that should dig deeper into optimizations, and hopefully we get the whole thing working.